Hello everyone, welcome to watch this video. In this video, we're going to introduce you our previous colleagues' works. They are working in UC Riverside and also the Network Lab of IIS Seneca in Taiwan. The authors of this paper including Huang Li and Chen. And their paper, the title of the paper is they propose a mixed method called PRoPHET Plus, which is an adaptive PRoPHET-based routing protocol for opportunistic networks. First, we want to introduce you what is the opportunistic network. It means those not very stabilized networks, especially that needs to contact. For example, if you go to Starbucks and you log in into the Wi-Fi of Starbucks, then you found that there might be other customers. They do use similar internet connection. Then you can say that you meet this guy or this girl with serendipity, and this based on the opportunity. So the opportunistic words comes from such an idea. And the PRoPHET plus comes from the sci-fi movie, The Matrix. If you remember that they do exist someone who could predict whether the character knew he uh, will let the vase drop or not, then I think the title of this method is based on that. They're trying to analyze and also all the combinatorial combinations of different parameters of what we can improve that. And what will be the real-time applications of this, besides the beautiful titles? The background and philosophy is explained as follows. First, it has been used in ad hoc networks that has applications either in military or in the space mission. For example, the rovers or the specialized robots that has landed on Mars. So for the message fairing, meaning that you want to deliver the message correctly. But however, when we consider the context of those rovers or the robots that has been dispatched to uh, dig out the exactly content of such as the atmospheric composition of the Mars or the soil, the content of the soils, or uh, the recordings of the skies or the clouds over this unexploited planet, then we need some routinely based robots to help us to find out more data and collect them correctly. That needs a very good ways to do that. So from table 1 is the properties of those network scenarios in this study. The device is called iMode. This is a very, very small chip that has been designed specialized for embedding sensors, like the sensors of humidity, the sensors of wind detections, the sense of gravity or vibration, etc. And also they do exist the networks because we expected the devices, they have to communicate. And the way that it choose Bluetooth, probably just because the Bluetooth has been developed, and especially the communication methods of Bluetooth, they have been developed for to be resistant of the interference during the communication. This depends on the way they have been coded for. And what will be the duration days? It including 4 days of simulation, because we might expect that those are very, very routine-based robots, when they mining the informations of those newly visited planets, they usually just contact after they have accumulated enough data information. And also the devices that has been participated, including 274 devices. The number of contact is near 30,000, and also the average contact per pair per day is around less than one third of it. Now, what they have uh, tried in this philosophy, they did a very, very solid work, including they tried to test the different factors individually with the method. Originally, from the firstly proposed method that comes from the Duke University, which is called epidemic routing. Actually, what they meant is that once those robots, once they contact with each other, if there exists some chance for delivering the message, then they deliver as quickly as possible. That's what they have assumed. But however, this will result in some very, very traditional uh, network research issues in even the traditional Ethernet design. That means the flooding. Because the flooding of packets around the world in this internet world, the receiver, they might not have that much capacity, or the quotas that they can carry is limited. So once you receive too much, it will get exploded, or the packet might drop. So the best ever delivery during each contact, the original ideas come from the Duke U, has been improved since at least from 2004. And in this paper, after a lot of pioneering trial, they're trying to propose the major contribution is the mixed valued functions. That means they're trying to consider the factors, including buffer, power, bandwidth, popularity, and the predictability values of the devices. The buffer assumption comes from that there might exist different specialized robots for the space mission. So, and also the same for the power, because their size might different, their function might different. So their power and also the encrypted buffer are different, and also the bandwidth of them might be different. Because, for example, if you have robots that try to take the films of videos all the time, then it might equipped with larger bandwidth delivery sensors. But if it's just for digging the humility of it, humid, then the bandwidth might be small, and so on. And the mixed value function means that they try to consider every aspect of it. So this is very makes sense, but because they try to show you the exactly ways of that. The way they're trying to do the profit, the specialized method, what will be the difference between the previously mentioned best effort epidemic routing? Actually, they try to record it, the specialized delivery ratios when the nodes contact. When the deliver, especially the message bearers, when they contact and they try to exchange information, they have to report to each other about how best their previous performance is about. So if they previously, including 10 delivery tasks, they have delivered 8 packages successfully, then they will show that we have 80% of delivery ratio, and so on. That means their reputation between different devices. And the devices who try to ask for the other device's contact will evaluate this according to their self-evaluated ratio. Now let's check So this is what the profit method is about, the basic contributions comparing to the best ever, the flooding values of delivery. Now they're trying to do in this four subfigures about the more detailed improvement. A little bit improvement could just result in a little, maybe more miraculous effect. So I guess that's why they consider the profit plus the buffer size, because previously they do exist some simulator, and the simulators assume that the devices they only have uniform or maybe simplified all uniform equipment. But in this A, B, D, these four figures, they consider the way that either the variety of devices has either fixed buffer or randomized fixed buffer. So the A is for the fixed buffer size, the B is for the randomized buffer size. We can see that once we consider the buffer size, the delivery ratio comes from a little bit, maybe 10% of increment of it. But for uh, the bottom two figures, they include the power of devices. You see that even when the power of the devices, if it is the randomized powers of the assumptions of the devices, then the profit plus the power consideration has been highly delivered uh, when the power consideration has been put for 5,000 watts. That means the higher powered equipment, if they have been tuned up, optimized, then the delivery ratio will be increased very quickly. But however, on the right hand side and also the bottom side, if we including the bandwidth, the delivery part of it, we maybe see a little bit of improvement of it. So this is some individual part that we want to show you. The same thing happens when the F subfigures, that including the window size, including consideration. What does that mean? They're trying to track uh, whether the window size, that means if you have one buffer, they're trying to deliver the package. And one small package of window size, including different pairs of deliver. That means if you have a mailbox, but if you have from one sender and one receiver, or you have 12 sender and 12 receiver pair, or 24 sender and 24 receiver pair, where that makes the delivery ratio of this specialized method different from their simulation. It does not matter too much. Now it goes to the tuning up procedure, because once the individual factor has been tested, they try to combine all those factors together. This is for the day. Starting from 1/2 day, 1 day, 1.5 day, 2 day, 2.5 day, and 3 days, the delivery ratio needs at least to reach 60%. It takes at least 1 day. Uh, this is for profit plus only buffer, but for the profit plus only power, to reach the delivery ratio to 50%, it might take at least 2 days. But for profit, including the score, this is so-called the mixed strategy of tuning. They consider the buffer, the power, and also other factors, the bandwidth that has been considered, and they try to tune up that. We found that to reach the best efforts of 50% of delivery ratios, at least it takes around 1.5 days or 2 days. So after the maximizations of the tuning, you see, comparing to the subtitles of this figure, they tune up the constant that has been assigned, especially the weight of the factors, those 5 factors, differently. And this is the best results that they have exhibited to us. It takes 2 days to do this. Now, what will be our thoughts? First, we know that they're trying to compare different factors individually and also the weighted functions of factors together gradually to take care. But you see, there might still be some space for improvement. That means when we check the evaluations of the simulation results, they at most reach like 50% of the delivering rate. That means the loss rate is still high. How can we do that? Maybe there do exist some ways that comes from the queuing theory that could come into the assistance of the design of that. And besides, there might be some dangers for their considerations of those paper. That includes once they try to dig into some specialized factors and modify the assumptions of the general ones, they might be in touch with the more detailed of the designs of the sensor. That means we cannot just do some paranormal viewpoints of how robots has been designed. Of course, when we analyze it more detailedly, we'll be able to do that. But even when this part for the mixed strategy that sounds very familiar like the best strategy for the investment, it could at most deliver like 50% or maybe 60% of that. That means maybe the more detailed assumption has some trouble, but if we focus on the queuing part of analysis, we could help that in the other way. So if you are interested in some further study of this paper or the investigations of the work, you probably can contact the delay tolerant group, where the professors of delay tolerant groups, including Professor Kevin Fo from UCB, and also including another professor from Colorado University. I think both of them, they are the organizers or committees of the delay tolerant networks. And according to our previous study, there do exist some interesting study that including the underwater simulation. Like they put the sensors inside of the water, and they do exist some occasional issues, such as the sensor might be able to be swallowed by fishes. They do exist such kind of casual conditions. But if it's a space mission or those are crude environmental uh, simulations, a lot of issues need to be considered. So, if you're interested in some further study or discussion with you are welcome to browse our website, Algorithmic Research Incorporation. Thanks for listening to this message. We will see you next time. Bye.